Hello, everyone. My name is Mike Miller. I'm a senior manager at AWS of the AI devices team. We're the team that was responsible for bringing you Deep Lens last year, and this year launching the AWS DeepRacer product. Thanks for joining us here on the Introducing AWS DeepRacer webinar. We're going to spend a few minutes walking through some of the background and how we got to where we are, and then we'll end with some questions. So what's around the bend for us today? Lots of driving puns, so apologies all around, both for myself and the ongoing punniness you'll see this year, because you can't launch a car and not make any driving puns. So here's our agenda. We've got a little bit of the background, the origin story, where we came up with the idea. RL for the Sunday driver, where I dive into some of the theory of reinforcement learning. We'll look under the hood, and you can see I've got a car here, so I'll use that as a prop to show you some of the components of the car. We'll talk a little bit about the service, and then finally talk about how the rubber meets the road and how you can get involved and what is in store for us for the rest of the year. Well, let's jump right in. You might have heard Andy announce at re:Invent Keynote end-to-end support for reinforcement learning in Amazon SageMaker. Let's just start there. So reinforcement learning in the broader AI context falls into an area that's occupied by supervised learning and unsupervised learning. Now, deep learning algorithms traditionally fall into broad categories based on the amount of training data required and the sophistication of the deep learning models. In supervised learning, you typically have a lot of training data, and this leads to models that can be very sophisticated and highly accurate, for example, computer vision or speech. And what happens here is you use this training data in a labeled fashion to train the model. So for instance, if you wanted to, say, train a model for how to recognize different flower types, you would get thousands of pictures of flowers. You would label them all. Okay, this one's a rose, this one's a chrysanthemum, this one's a daffodil. And then you would use those to train your machine learning model. In unsupervised learning, you still have a large amount of data, but typically this data is unlabeled, and your goal is to try to find hidden structure in this unlabeled data. So for instance, anomaly detection, detecting data outliers. A third complementary approach has emerged called reinforcement learning, or RL. RL takes a little bit of a different approach, and it enables models to learn complex behavior without pre-labeled data. So let's give you a quick example of very high level how this might work. So for instance, if we wanted to use reinforcement learning to teach a model how to play Pac-Man, luckily, Pac-Man, the game, is pretty simple. Pac-Man only knows how to go up, down, left, or right. So that makes it easy for the algorithm to play. Also, luckily, we have a simulation environment where we can let the algorithm try and play Pac-Man. And of course, this is the game. Finally, we assign rewards for the desired behavior that we want the model to learn. In this case, we assign rewards to score as many points as possible. So in reinforcement learning, we actually allow the algorithm to play potentially hundreds or thousands of times, in this case maybe thousands of games, and instruct it to maximize the rewards. So in Pac-Man, maybe it's learning to eat fruit while avoiding being eaten by a ghost. So RL's superpower is learning complex behaviors without requiring this pre-labeled training data. In other words, reinforcement learning can learn to make short-term decisions while optimizing for a longer-term goal. Reinforcement learning models have been applied successfully in a number of practical use cases. You can see a few of them on the screen here. Of course, autonomous cars, fleet logistics, financial trading, data center cooling, optimizing supply chains, etc. So now, while this technology is exciting and broadly applicable, its complexity puts it out of reach of most developers today. Now, if we think about that for a moment, we find ourselves in a very similar situation with deep learning. So here's a quote from one of our second place winners of a Deep Lens hackathon we ran last year. And this situation with reinforcement learning made us think a bit about what we did with Deep Lens to put computer vision and deep learning into the hands of developers. Developers have told us that they love this approach. We hear similar comments to this quote over and over, that developers are able to use Deep Lens to get hands-on and get a better intuition about how deep learning and computer vision can help solve their business problems. And so we asked ourselves, can we help developers get rolling with reinforcement learning, literally? After much brainstorming, we decided against building a scale model data center and using reinforcement learning to manage the cooling. Though to be honest, that would have been pretty cool. And instead, we landed on AWS DeepRacer, a fully autonomous 1/18 scale race car driven by reinforcement learning. With a camera in the front to see the track and an Intel-based compute platform inside to perform the model inference. It's built on top of a 4x4 monster truck RC car chassis. And I'll definitely get into the details of what's under the hood a little bit later. Of course, to enable the end-to-end reinforcement learning experience, we introduced the AWS DeepRacer console. This console provides a simple way for developers to get introduced to reinforcement learning through model configuration, training in a virtual environment, and evaluation of how well the model drives on a virtual track. It provides all the tools that developers need to get started quickly and iterate on their reinforcement learning models. So as we built this console and started testing the car prototypes, we realized, what's a car without a little competition? And so we also announced the AWS DeepRacer League. Developers can train their models via the console for the fastest lap time on a given track, and then can submit those lap times to an online leaderboard, or get the chance to compete in person at AWS summits throughout 2019 around the globe. And actually, we launched the AWS DeepRacer League at the 2018 reInvent in Las Vegas this year. We had a one-day event where we took over the MGM Grand Garden Arena and set up multiple tracks for developers of all skill levels to come down, train a model, and race them on these tracks. We recorded their lap times, and the 3 top lap times advanced to a final race, which was held the morning before Werner Vogel's keynote. Check it out in this video.
I'm excited to announce the launch of AWS DeepRacer, which is a fully autonomous 1/18 scale race car driven by reinforcement learning.
On your mark, get set, go!
Every single one of you will be handed a DeepRacer car.
Congratulations, Anish, the winner.
There can only be one grand champion, and that honor goes to Rick. Come on out, Rick. There he is. The fastest developer in the room. And look at that trophy. That's the real deal. Great stuff, guys. Congratulations to all 3 of the finalists, and thank you all so much for coming out and being such a involved audience for that presentation. This really was a showcase for this technology, but this is just the tip of the iceberg. As I'm sure you remember during the keynote address yesterday, the DeepRacer League 2019 was also unveiled, and that's going to give you folks a chance to compete at 20 different AWS events throughout the world starting next year, all culminating, of course, with another championship race right back here in Las Vegas at reInvent 2019. So between now and then, make sure you're ordering your DeepRacer car, test it, tune it, maybe enter some of the preliminary races, and we might just be seeing you up on stage and possibly be crowned DeepRacer Champion 2019. Thanks so much.
Okay, well, let's get into a little bit of the theory. I'll keep it pretty high level and explain a few ways for customers and developers to go a little deeper on their own. So the idea around which reinforcement learning is built is used quite often, perhaps daily, by humans. So think about the last time you used a reward to incentivize the right behavior. For example, when training a pet, treats are used to incentivize the desired behavior. Training can be for simple actions like sit or stay, and can extend to more complicated series of behaviors, like you sometimes see in dog agility courses, where they crawl through tunnels, jump over hurdles, and weave through poles. So, reinforcement learning is about creating a model that can be used by an agent to choose which actions to take in an environment in order to achieve a specific goal. So if we think about this in the AWS DeepRacer simulator and the concept of driving a virtual car around a virtual track, the agent is going to be the virtual car. The environment is the racetrack and what the car can see of the racetrack through its camera. The actions are going to be the steering and the throttle used to control the car. And of course, the goal is to complete the track as quickly as possible without necessarily deviating from the track. So as DeepRacer drives around the track in the simulator, it takes pictures at the specific frame rate of the camera that's mounted on the front of the device. And we mimic the same behavior in the simulator to ensure that the training is applicable, whether it's driving in the simulator or driving in the real world. So in the simulator, the FPS, or the number of pictures per second that the virtual camera can see, is about 10 or 10 to 15, which is the same as the car. So these pictures from the front of the car represent the state of the environment. And the agent, the car, uses the state, the picture, and the model to decide which action to choose. How should I steer? How should I control my throttle? So initially, the untrained reinforcement learner model will choose actions at random to explore the environment. But over time, it will train and notice which actions lead to better outcomes. This is called exploration. There's another state that the model will get into called exploitation. And that's when the model starts to exploit some of the knowledge that it's gained to repeatedly take actions that lead to better outcomes. Now, as a developer, you can determine how soon your model should go from exploration to exploitation. And of course, there's trade-offs here. If you try to exploit knowledge too soon, you forego potentially finding a better action, like a better path around the track. However, if you explore too long, your model will take a very long time to train, as it drives randomly exploring around the track and calculating reward functions. But how does the model know the best outcome for a particular action? The model is going to choose the action that it thinks will lead to the outcome with the highest reward. After each action, the simulator uses the reward function, which contains the logic to quantify how good or how bad an outcome is to calculate the reward of the outcome. Now, this reward function, in our case, is written in Python. We provide a few different samples, a very straightforward reward function and a more complicated reward function. And they're about 10 to 20 lines of Python, so they're actually relatively easy to understand, even for the novice developer. So back to the learning process. So one such loop where the reward is calculated and the action is determined is called a step. Now, we call the set of steps from the start state, which is where the car respawns on the track, to the next terminal state, in other words, finishing the track or where the car, crashes too far off the track, we call that an episode. So we've got a number of steps that form an episode. Now, after a set number of episodes, the model will use the experience obtained to update itself and then restart the process to get more experience, followed by more training. And so that's really where the iterative nature of reinforcement learning comes into play. During this training, the model is learning which actions in each state will lead to higher future rewards. The model tries to maximize the cumulative reward that can be received from any state by choosing the action in each state that leads to the best outcome. So once your model is trained, you have a function. We call it the value function. And this is a function that knows what the cumulative reward is for all actions in a specific state. And so all the model has to do is select the action with the highest reward, and that'll give the best outcome. Now, this mapping from state directly to action is called the policy function. So you might think like, hey, this works when you can quantify every possible state action reward set, and maybe you just code it up into a lookup table. But for many reinforcement learning domains, you can't explore every state action combination. So how do we know the reward value associated with every action? So to do this, you approximate the value function. So we're not going to go into how we do this, but it's a key method used in reinforcement learning that's left up to you to go do some research on. And in fact, this also is where neural networks come into play, and you get to deep reinforcement learning. And that's actually how AWS DeepRacer is driven. So that's about it for the theory. We're going to get under the hood now and take a look at the key components of the AWS DeepRacer device and platform. As I mentioned, there's three key elements. There's the simulator, where you train your model and evaluate it in a virtual environment. There's the autonomous race car, where you can take the model that's trained in the virtual environment, download it to the race car, and use that to drive the car autonomously. And then, of course, there's the DeepRacer League. So let's take a look at each one of these in a little more detail. So first, let's take a look at the process by which you use the console. And we'll also look under the covers of what's behind the console and what services we use. So here you can see in the console, you're able to create a model, configure it by specifying some parameters, and defining the reward function. So that's really the first step. Those elements combine and are used to configure the training job and to perform the action of training, which involves two different services. AWS RoboMaker, which is AWS's new robotics platform that provides the simulator that we use, and Amazon SageMaker. That's where we execute algorithms in the notebook, and we integrate with Intel Coach as the reinforcement learning framework to ensure that over time the model learns. So once you've trained the model and your virtual car is able to successfully drive around the virtual track, you can evaluate the performance of this car's driving skills on a potentially different track or on the track that you trained it on. Now, this evaluation step is important because here's where you can execute the model to drive the car around the track and earn a lap time. The lap times for the different tracks can be submitted to our leaderboard, where you can compete in the DeepRacer League. Once you've got a trained model, then you can download it to the DeepRacer car to validate what we call the sim to real transfer and see how the car drives in real life. If you're not happy with your model's performance, you can clone the model, potentially tweak some of the parameters or the reward function, and train it again and go into a cyclical process here for improving your lap times. So let's take a quick look behind the scenes at the architecture of the console. So as I mentioned, we did a bit of work to ensure that we had an easy to understand and fun journey for developers of all skill levels to learn reinforcement learning. But behind the scenes, we're leveraging a lot of the same services and building blocks that AWS builders are able to access on their own. So when you use the AWS DeepRacer console to create a new model, the following happens. So first, we prompt you for your reward function and for the hyperparameters that might define, that balance between exploration and exploitation, and some of the other parameters of the algorithm and of the learning process. The DeepRacer console will then kick off a series of step functions to orchestrate the creation of the simulation environment. So that's just a complex way of saying that it starts an Amazon SageMaker container and an AWS RoboMaker container in your service account and links the two up. It passes the right parameters to start the training. And then as the model trains, there's a set of output that's stored or made visible in the DeepRacer console. So as you can see in the slide, we actually route the first-person video of the car driving around the simulated track to Amazon Kinesis video streams so that you can see as if you were driving the virtual car. And it's actually a very interesting view because you can see when the car starts to transform from or transition from exploration to exploitation, because your first-person view will go from kind of randomly driving around the track and veering off to actually starting to follow the track more closely. There are other metrics from training, such as the calculation of the reward function, that are stored in Amazon CloudWatch. This data is presented in the DeepRacer console as well in a graph. And so you can see for each episode the cumulative value of the reward function. And in theory, this starts off pretty random and then over time starts to grow as your model begins to exploit more of its knowledge and learns how to maximize the reward function. Finally, as you see on the slide here, we write some data into Amazon S3. We have an S3 bucket where the trained model artifacts are stored. And this is the same place that once you obtain a physical car, the DeepRacer car, you can grab the model artifacts from this S3 bucket, download them, and then transfer them over to the car so that the car can then drive autonomously. So speaking of the car, let's take a look. I've got a slide here, and I'll take a look at the car itself, and we'll talk through each of the components. So here I have the DeepRacer vehicle. As you can see, like I mentioned, we're based on a 1/18th scale monster truck chassis that's four-wheel drive. Don't let the shape of the car trick you. The front, here is the wide end because it's got the camera. So we had to make a few kind of interesting design decisions. And then we've got a clear portion on the back here where we've got an LED light pipe that feeds into so that developers can kind of customize the look and feel of the device. If I open the hood here, we can walk through some of the components that you see on the screen or in the slide. So up on top here is one of the two batteries that's on the device. This is the compute battery. It's a USB-C battery that then powers the main logic board, or what we call the compute portion of the device, which is housed inside this large black piece that's pinned down to the top of the chassis. That's running an Intel Atom processor. It's got 4 gigs of RAM and 32 gigs of eMMC for storage. And it's expandable. So you can see over here, on the other side of the device, we've got a micro SD card slot. So developers can use that to expand the storage, either to write more data or to load significant amounts of data into the device. On the two sides of the front of the device are our antennas for the 802.11ac Wi-Fi. The compute board is running Ubuntu 16.04.3 LTS. And you might have noticed there's a port over here on the side, a full-size HDMI port. So just like the AWS Deep Lens, a developer could plug in their monitor into the car, plug in a keyboard and mouse into our extension USB ports, and they can access the Ubuntu desktop, just as though this were a little computer. And it allows for more rich debugging and programming available. The device itself, on top of Ubuntu, is running ROS Kinetic. ROS is Robot Operating System, which isn't really an operating system, but a set of libraries that help translate the signals from the model into the physical instructions for the device. You can think of this as a robot where the commands are, steering left to right and throttle. In order to execute the model on the device, we run Intel's OpenVINO toolkit. So we use that toolkit to both optimize the reinforcement learning model as well as to run inference and execute it on the Intel Atom processor that's in the device. Finally, through the port here, you might be able to see a little blue thing. That's the car battery. So the compute battery will last you for several hours of runtime. The car battery, significantly less than that. We say to estimate around 15 to 20, 25 minutes of runtime, depending upon how fast you're driving the car. The camera here on the front is a 4 megapixel camera, and it outputs an MJPEG stream. It's the same camera lens and assembly that we used on the AWS Deep Lens device, so it should be pretty familiar. There's another port on here, a micro USB port, and this micro USB port is used to connect the device to your computer for the initial Wi-Fi setup and to download trained models to the device. Then that's a USB-C, which is just for power, and as I mentioned on the other side is a micro SD card. Now you'll notice we did include a few additional USB ports on the device. So next to the camera up on top, you can see we have 2 additional USB slots, and that's for future expansion, potentially doing stereoscopic vision or other sensors. There's also a USB port on the rear of the device, which is an extension port for potentially a neural accelerator or another accessory TBD. So that's it for the device hardware itself. Let's next get into some of the software that's used on the device. Okay, so this slide shows us a little bit of the software architecture on the DeepRacer device itself. You can see the top row there, the model optimization step that I mentioned earlier, where we use Intel's OpenVINO model optimizer to optimize the model into a format where it can run efficiently on the Intel Atom processor. The second row in the slide there gives you a glimpse of the runtime actions on the car. So if you start on the left-hand side, the video feed from the camera goes through the media engine and pops out as MPEG video. As I mentioned, we lock that at 10 FPS so that OpenVINO can keep up and we can have a frame rate that matches our simulation environment. If we allowed that frame rate to fluctuate, we'd have some difficulties with the sim to real transfer. So you can see out of that video MJPEG box, you see 2 streams there. You see one going to OpenVINO to actually perform the inference, so allow the model to see the state of the environment and make a decision about what action to take. You also see underneath it where it says web server video. So this is actually a pretty interesting component of the software on the device, and it's actually how you manage the device itself. The device will run a web server when it's powered up that you can connect to from your phone, laptop, or other browser. This gives you an interface where you can monitor the car, you can see the video from the front of the vehicle, and then you can also control some parameters of the car and start it and stop it. So that's why we see the video getting piped to the web server. If you continue along the path on the top row there, the OpenVINO toolkit is used for inferencing. The inference results get generated. Again, if you recall our agent action state kind of diagram, the inference results basically tell the car what actions to take, so where to steer. Those steering signals are then translated into electrical signals that the physical elements of the car know how to understand. So telling the steering servo to go one way or the other, or telling the ESC, which is the throttle controller on the device, whether to step on the gas or not. You can see just under that set of boxes there, we have manual drive. And so we did enable autonomous mode as well as a manual mode for driving the car, just to verify its functionality, and if you wanted to test any capabilities, you can drive it in manual mode. So in manual mode, on the web interface, you'll see the video from the front of the car. You'll actually also see a video joystick that you can use to drive the vehicle yourself. All right, so let's talk a little bit about where the rubber meets the road, or how you can get involved. So of course, we launched the pre-order of AWS DeepRacer on Amazon.com. It's currently available for US customers only, although we will be announcing more regional and geographic support over time. Just search for DeepRacer and you'll find it on Amazon.com. We've got a promotional price happening right now where you can pre-order the device for $249. The regular price is $399. And that promotional price won't last for long. So if you're interested, I would encourage you to order it now. You can also visit the AWS DeepRacer page on aws.amazon.com and sign up for preview access to the console. We expect that to be available in early 2019, where we'll start inviting users into the console to help give us some feedback about the initial trials. You can also explore the Amazon SageMaker RL example notebooks and tutorials to gain a deeper understanding of reinforcement learning. And specifically, we actually created a DeepRacer sample notebook that's available in SageMaker that customers can use in place of the console to build, train, and evaluate a model for DeepRacer. And I'll tell you how to access that in a minute. But what that does, it gives you a more code-forward approach to learning how RoboMaker and SageMaker fit together, along with the details of the hyperparameters, the reward function, and how the training and the algorithm operate. So in order to access that sample notebook, you'll open a SageMaker notebook, and once it's started, you can go to the SageMaker Examples tab, scroll down to the reinforcement learning section of the samples, and there you'll see a notebook called RL_DeepRacer_coach_RoboMaker. And you'll select Create Copy on that notebook. That notebook will open a copy in your space, and you'll be able to walk through it just like you can any other hosted notebook to create, train, and tweak your model. The sample actually uses AWS RoboMaker for the simulation, and it uses the same DeepRacer simulation app that we used at reInvent to train our models and drive the cars around the track. So you'll be using the same track layout, the same physics, and the same configuration that we used for DeepRacer. And if you keep an eye on that, we'll probably be updating that over time and making sure that that stays current with all the changes or improvements that we make to the DeepRacer simulation bundle. You can view the training stats in the simulator, so you can open up the AWS RoboMaker console itself and view that training job to see the simulator. In that sample notebook, we actually plot the metrics that are coming from the simulation. So if you recall, I mentioned you can see the reward function and the graph of the reward function over time. This sample notebook does a quick approximation of that, so you can see how your model trains over time and see the values of the reward function after each set of steps, after each episode. Customers who received a DeepRacer device at reInvent can use this method to train a model and then download it from the specified S3 bucket to your car. And that's how you can get a leg up on training your car to drive autonomously. I would encourage you to keep an eye on the AWS DeepRacer forums. And if you have questions or comments, either about the training and the simulation, or about the device, if you were one of the lucky ones to come home with a device, visit the forum to ask questions and see what others are up to. We've also got a few resources there and links to other documentation and resources for you to access how you can potentially print out a track or find other mechanisms to test your car in the real world. So that's it. Thank you so much for joining me for the introduction to AWS DeepRacer. I hope you learned something. Definitely take a look at the Amazon SageMaker RL sample notebooks to get a sense for how all the pieces fit together and get an early peek at what AWS DeepRacer will be able to provide. Thanks.